All right. Thank you all for being here. So I get to talk about something a little different, but yet the same as Pavel already introduced, the idea of we're really here merging the idea of data science as a tool, but for our own disciplines, right? And so I'm actually a climate scientist, data scientist. So I'm actually a joint faculty member both in CDS and in Earth and Environment. And I think I really being able to be joint between those two really exemplifies, I think, what CDS is all about, as Azar already told us today. So I talk a lot about opening this black box that is the black box of AI. And I did try to create a picture of a black box with Earth inside because this is what we do. And I thought it would be funny to see what I did. So here it is. I asked the LLM to create a black box that had Earth inside. And this is what I got. And I said, OK, fine. But it needs to be black all around. I don't want to see it from the outside. It's not a black box then. All right, and then it did this, and I said, okay, good, but I can still see the Earth. It's not a black box. And so I said, make the walls all black. And there we are again, right? Keep going. Okay, stop showing the Earth on the side of the box. I was getting annoyed here. So it stopped showing the Earth. It took it away, right? And finally, now show a view. Good, we're getting closer. That can see the Earth inside, so this did not work. Hence why my front slide didn't show anything. But my point here is that AI is a great tool, but it's not perfect. And so as scientists, we have to remember that it does silly things like this all the time. And our goal as scientists is to get the right answer for the right reason, right? Not just to get any answer. And so today I want to tell you about what my group does. So what we do is we both develop and use data science tools to leverage our imperfect modeling and models and ideas about how the Earth works. We ask questions about when, where, and how are environmental conditions predictable. And the overall arching goal in my group is to responsibly harness AI to anticipate these human Earth system futures in support of a thriving society ahead. So why BU? Why CDS? So actually, I just showed up here myself in September. I was at a university in Colorado as faculty there for 12 years. So I just made the move, making a decision like many of you are making now. And the reason I chose BU and CDS is I've never seen anything like CDS before, and I've spent many years looking. A place where students and researchers can come together to really tackle these problems that require we all communicate with one another across disciplines, right? Not just in that one topic of climate or in that one topic of computer science. So I want to give you just a flavor, like Pavel did, of the types of work that my group does. So let's talk about hurricanes. So thinking about hurricanes, but not looking at now, let's look in the past. So we can use AI to wind back the clock and simulate tropical hurricanes over the last 1,000 years and study what they were doing and why. So this is a really awesome project that's led by my postdoc, Muting Qian. But those other two circles, those are undergraduate researchers working with our team and working with Muting right now. And what we did is we have collaborators in Taiwan who have a database of Chinese written records, okay, of temperatures and winds over the last 1,000 years. This is amazing. Well, what we can do is we can take this data set and use this information, and what we find is that there was a peak or extra hurricanes, in this case typhoons, hitting the Chinese coast over the 1600s. Now the question is why? We're climate scientists, we want to ask that question, right? Why was this happening? Now we can run what we call a physics-based climate model. Many of you have heard of climate models probably before. We use physics like F equals ma in these models. We can simulate this same time period and we see slightly increased hurricanes or typhoons at the same time. But here's the problem. This took months to run. It was so expensive. It had a supercomputer running to make this simulation. So we can only do it once. But what's so amazing now with AI weather and climate models is now we can do the same thing for much cheaper. So here's an example of an AI model on the left and our truth or our sort of observations on the right. Now, you might look and go, wow, those look identical. Yeah, it's really easy to make simple, pretty pictures. Don't be fooled. Our job is to go in and say, are they identical? How good is that AI model? Where does it need to be improved? And can we use it for the task of understanding this tropical cyclones hitting China? But because they're fast, we don't just run one, we can run a lot of them and explore a range of climates and paths that could have unfolded. So we've done this, And we've confirmed that, in fact, tropical cyclones in these models look like reality, which is pretty amazing. Furthermore, if we go back to those historical documents that showed us hurricane increases in the 1600s, we find that the AI model can replicate that same phenomena. Why is this awesome? Because now we can ask the question of why. Why is this happening? And I won't go into all the details, but it turns out it has to do with what the sea surface temperatures were doing over this time, and now we can explore our physics and our causality, which is what it's all about. All right, another example of how we're looking at AI, and in this case, we're actually developing AI tools, is watching AI models learn. So specifically, think about when you've already seen a baby today. Here's your second baby. Think about how you learn as a kid. So first, you start learning a little bit of information. Maybe you can then build the blocks, and you go through time, and then maybe you're building buildings yourself. And what's happening here is you're gathering information and using that information to learn. And this is how we train AI models in the same way. We feed it more information, and it learns over time. Now, most of the time when people talk about AI, they only show you that last picture, the learned AI model. But what we're doing is instead we're watching these AI models learn through time. We're watching them, if you will, get smarter. And we call these checkpoints. You can think of those as birthdays. So here's an example of work being done by Annabelle Wade, a first-year PhD student in my group, and she's helping myself advise 3 undergraduate CDS students. And the idea is we're going to watch AI make the same forecast over and over and watch how it learns. So here's an example. Anybody here from the West Coast? I know at least one. Okay, you guys have heard of atmospheric rivers, I'm sure. These bring a lot of water to the West Coast. They can be very extreme and bring extreme winds, shut down airports. So let's watch AI learn to forecast this event 7 days ahead. So here's its first forecast. The gray is what actually happened. I mean, it got a storm in the right spot, but it's pretty skinny, right? It's only 1 year old, though. This is checkpoint 1. As we move in time, okay, now it's in the wrong spot. But as we move forward, it gets older and older. And here by checkpoint 15, it's actually looking okay. This is 7 days ahead. That's kind of far, actually. All right, let's keep going. So far, so good. Let's keep going. So we're at checkpoint 23. Checkpoint 25 looks fantastic. That's a really great forecast for weather. And then it forgets. So this AI model learned what it needed to learn and then promptly forgot. And the question is, what is going on? We don't know. This result's actually 2 months old. So right now what we're doing and what we're doing with these undergraduate researchers is they're running more examples of this to see if it's just this event or if it was many extreme events that it's forgetting during training. So we're asking, why did it forget and how do we stop this from happening? And finally, as I wrap up, those were weather applications, but I want to point out, I said Earth system when I introduced my group. We are working across more than just weather. And in this case, we're looking at the land surface and how changes in the land surface by humans may change in the future. And we're using AI to take an imagery from space, Landsat imagery, and map it to how much humans are impacting the land surface. You can think of it as putting in parking lots or farms or roads. And we can compare this through time and look at changes at different locations and how the human footprint has changed. Moreover, we're asking the question, how has and will human development be impacted in the future by climate hazards? So in this case, a landslide. So we're doing this across the Earth system. And just as I wrap up here, I will point out I skipped the most important bits of what it means for me here to be a scientist, and that's actually my family. I like to bring this up. They're an important part of my life and my work. My husband's actually a professor here in Earth and Environment as well, and they're my 2 sons, 11 and 7. But this is my family, but I have a work family here too. So this is my research group, and I'd like to point out specifically for this crowd who's interested in research, we right now have these undergraduates all working in our group, and we're looking at opportunities to allow for more students to get their hands on climate and environmental data to experience how it interacts with AI. So with that, I will just say thank you.